Hello, my name is Putri Marfanti Onibala. On this occasion, I will discuss about thermodynamics of an open system and the chemical potential. The first, thermodynamic quantities in an open system. Thermodynamics defines a system as the part of the universe under study, i.e. the part in which observations are made. The universe and its surroundings interact with each other, and depending on the type of system, the exchange of matter and energy takes place. The classification of a system depends entirely on the movement of energy and matter into or out of the system. Before that, what was an open system? Systems in which the exchange of energy as well as matter takes place are treated as open systems. For example, water is boiled on a stove without a lid. The container behaves as an open system because it receives heat energy from an external source, and the material released is water vapor. In an open system, the first law of thermodynamics does not apply. The Gibbs equation do not apply in the form defined but in the exchange form. The second, what is the chemical potential? Chemical potential, also known as a partial molar free energy, is the change in a system when 1 mole of a substance is added to it. The Gibbs change was introduced by Willard Gibbs, where the Gibbs change is equal to the volume times the change in pressure minus the entropy times the change in temperature. This equation can be reduced to the formula for chemical potential. Chemical potential plays a very important and major role in thermodynamics, although it seems that chemical potential is only part of the remaining of the molar Gibbs function. Chemical potential can be thought of as a measure of the independent tendency of a component. If the chemical potential of a component is not the same in each phase, there will be a tendency for that component to move from a phase with a higher chemical potential for that component to a phase with a lower chemical potential. When the chemical potential is the same in both phases, that is not tendency for a net transfer for one phase to another. The value of the chemical potential depends on the relative balance of a component present, not on the amount of the component. This makes the chemical potential an intensive property. The chemical potential is determined by the mole fraction, which is not from the respective n values but from the component present. The chemical potential represents the change in the Gibbs function of a system when a substance is added to it. The Gibbs function increases as n increases. For pure substance, the Gibbs function is the chemical potential is equal to the molar Gibbs function, so equation for a molar gas becomes chemical potential not only shows the change in when the composition changes, but also show the change in internal energy or under different conditions. One example for a system and well-known chemical potential is that of water and ice. If ice melts, then that chemical potential of water will be lower than that of ice. Vice versa, if water freezes, then the potential of water will be higher than ice. That's all from me. I'm sorry if there's a mistake. Thank you for watching.